All right, so today is still on section 8.4, but day 2 of 8.4. We're going to just kind of add on to what we were talking about with Pascal's triangle. And the new addition is this concept right here. Few things to know about what this says. So first of all, how do you read it? So this would be read as n choose r. So what it does is it counts the number of ways to choose r things out of n things. So this is actually, it is related to Pascal's triangle, and I'll show you that in just a moment, but it's also related to probability. N choose r counts the number of ways to choose r things out of n things. So here's what your formula looks like. This is one way to write n choose r, and then this is another way to write n choose r. Now this is not a fraction, okay? So if you accidentally put a division bar here, you would be marked wrong because it is not n divided by r. This symbol represents n choose r. And then, so you can use either this notation or this notation. Both of those equal this statement right here. So whatever your total number of things is, that goes on the top factorial. And then you take n minus r factorial here times r factorial, the number of things you want, the number of things you're choosing. So let me give you an example here. Let's say you've got 12 people on the tennis team. And you want to choose 2 co-captains. Okay, so the idea would be, let's say you got 12 people all lined up. This would count the number of different ways to choose 2 people from those 12 people. So like it could be the first and second person, or the first and third person, or the first and fourth person, and so on. Or it could be the second and third person, or the second and the last person, or the third, like it's all the different combinations. Okay, so if I'm going to apply this formula, it would be 12 choose 2. If I wanted to, I could write it as 12 choose 2 this way. And again, it's not a fraction, so no division bar. So then I would have 12 factorial on the top, and I would have 12 minus 2 factorial times 2 factorial. Okay, now let's see if you remember how this works. 12 factorial on the top, that's 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12. So I'm just going to write it like that. Then I would have 12 minus 2 factorial, which is 10 factorial. So that's 1 times 2 times 3 all the way up to 10. And then I have 2 factorial, which would be 1 times 2. Okay, well, if I cancel, I can cancel, let me get a different color. I can cancel the 1 through 10 and the 1 through 10 on top and bottom. And then I'll be just left with 11 times 12 on the top and 1 times 2 on the bottom. And then when I type that in my calculator, I get 66. So that means that there are 66 ways to choose 2 co-captains out of 12 people. Okay, so that is in a nutshell what this all represents. Now, how is that tied into Pascal's triangle? Okay, so here we go. So let's say, for example, here. What this one represents is choosing two things out of two things. So think about that. If you only have two objects and you want to choose two of those objects, how many ways can you do that? Well, there'd only be one way to do that. If I have two things and I want to scoop up two of them, there's only one way to do that. Let's say I have two things and I want to just choose one of them. How many different ways could I do that? Like, let's say I have a red thing and a black thing, and I want to choose just one of them. How many different ways can I do that? Well, I could choose the red or I could choose the black. There would be two different ways for me to choose one thing. Okay, let's say I have three things and I want to just choose one of them. So let's say I have a red, a black, and a blue. Let's say they're pens, a red pen, a blue pen, and a black pen, and I want to just choose one pen. How many different ways can I choose one pen? Well, there'd be three different ways. Okay, and so on. So let me just kind of add all these in here. And what I want you to notice is, do you recognize those numbers? And hopefully you do. These are the numbers from Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. These are the numbers in Pascal's triangle. So now what I want you to do is figure out another pattern. Okay? Remember when we would count rows and terms, we would always start with 0. And that is written here. It's just a little bit hidden, so let me highlight it here. We always start counting with 0. So remember how this was the 0th row? And this was the first row, and the second row, and the third row, and the fourth row. Okay, maybe you're noticing it. These 1s represent being in the first row. These 2s represent being in the second row. The 3s represent being in the third row. And the 4s represent being in the fourth row. And this 0 up here is in the 0th row. So this N right here is the row that you're in. And then this would be the 0th term. This is the 0 term in the first term. 0 term, first term, second term. 0 term, first term, second term, third term. See that? 0, 1, 2, 3, fourth term. So this R represents the term. All right, so we can use this idea of N choose R even with our Pascal's triangle. So here's where we're going with this, okay? Let's expand this out and then we're going to come up with a formula. So the expansion part, that's a little bit of a review from last week. So remember that this exponent right here represents the row that we are in Pascal's triangle. Now, if we're in the fourth row, our coefficients are 1, 4, 6, 4, 1. So I'm going to write out those coefficients. Okay, then I am going to take whatever is listed first, which happens to be an x, and I'm going to raise it to the highest power, which is a 4. And then that power is going to decrease with every term. All right, then let me see what color you do. Purple. Whatever is the second thing, so this is a positive y, that starts out at 0 and it increases the power. Okay, now for the purposes of writing a formula, what I want to do is I want to take these leading coefficients in blue here, and I want to write them in terms of n choose r. So let's go back a page. When we were in the fourth row, it was 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. So 1 is equal to 4 choose 0. And then this 4 is equal to 4 choose 1. And the 6 is equal to 4 choose 2. And this 4 is equal to 4 choose 3. And this 1 is equal to 4 choose 4. And then I'm going to put all these values back in there. And I want you to see if you can find a pattern. And then once you find the pattern, we are going to be able to write a general equation. Okay, so as you are looking for the pattern, I want you to kind of look at these numbers by the C here, and then I want you to look at these exponents and ask yourself, how do I get these exponents from these numbers? These exponents from these numbers? These exponents from these numbers? Okay? So, in general, we use n choose r. Okay, now remember, n was the row and r was the term. Now what I want you to do is figure out, how do I get this exponent up here on the pink from these numbers? So like here, a 3, how do I get a 3 from a 4 and a 1? How do I get a 1 from a 4 and a 3? How do I get a 0 from a 4 and a 4? Well, what you might notice is if I subtract those two, 4 minus 4 is 0, 4 minus 3 is 1, 4 minus 2 is 2, 4 minus 1 is 3, 4 minus 0 is 4. So I can raise it to the n minus r power. Now what's happening with the y? What's happening with this exponent on the y? This was a 0. Okay, look down here. This was a 1. Look down here. This was a 2. This was a 3. That was a 4. What you might notice is this exponent is exactly the same as this number right here. 3 matches the 3, 2 matches the 2, 1 matches the 1, 0 matches the 0. So this exponent is the same thing as r. All right, so this formula right here will get you any term in the expansion. So if I say I want let's say I want the second term, okay? I can use this formula and I can just go right to the second term. I would not have to write this whole thing out in order to find out what the second term is. So let me give you an example of that. Let's say we want to find the third term, okay? So we're finding the third term of x plus y to the fourth without having to write the whole thing out, which we've already done, okay? But let's pretend we don't want to have to do that. We just want to find the third term, that's all. So you need to remember that the exponent, that is the row that we went to. Remember, we went to the fourth row to get our leading coefficients. And then 3 is our term. So as of right now, I know that my row is 4 and I am trying to find the third term. The first thing listed is an x, and I'm going to raise that to the n minus r, to the 4 minus 3. And y is the second thing listed, and that gets raised to whatever r was. So here it was a 3. Okay, now 4 choose 3. Go back. Here was the formula, right? And you can certainly use that formula, but I also want to show you how to do it in your calculator. Okay, I'm just waiting for my calculator to pop up here. And I'm going to show you how to type in 4 choose 3 into your calculator. Okay, so go to a blank page and you're going to press menu and then you're going to press 5 for probability and then you're going to press 3 for combinations. So that's menu 5 3. Write that down, menu 5 3. And then you get this N choose R with parentheses. And in the parentheses, you have to specify what the two numbers are. So in this problem, we're doing 4 choose 3. So I have to indicate that I need N to be a 4 and R to be a 3. So I do that and separate it by commas. So this will represent 4 choose 3. The comma was down here below the pi symbol, just FYI. Okay, and then when I hit enter, I get a 4. 4 choose 3 is 4. So going back here, this is equal to 4. And then I have an x to the first and I have a y to the third. So this right here is the third term. Okay, now I want to show you that we already figured that out. I'm trying to scroll up. Okay, the third term. And remember, we start counting from 0. So this whole thing right here, this is the 0 term. This is the first term. This is the second term. Here is the third term. And you see that that is what we got here. Okay? So if you're ever told to find a specific term, you certainly can write the whole thing out and then count 0 term, first term, second term, third term, etc. Or you can use this formula, which is going to fast track you just to whatever term you want. Did you write down the N choose R in your calculator? Was menu 5 3. Okay, but we'll practice that some more. All right, so on this one, we want to find the 5th term of this expansion. So I'm going to write that formula out that we figured out, okay? And now we're going to put all the pieces in there. So this 8, that is the row of Pascal's triangle that you would go to, and the term is 5. So the N represents the row, so this is going to be an 8. R is the term. Now, X in the formula was the first thing that was listed. Well, in this problem, it's an A. So instead of an X, it's an A, whatever the first thing listed is. And then I do to the N minus R power. So I'm going to do to the 8 minus 5 power. Y from before was the second thing listed, and in this case, it's a 2B. And that's going to get raised to the R power, and the R was a 5. Now, make sure you put that in parentheses because you have to remember you got to raise the 2 to the 5th power and the B to the 5th power. And if you don't put parentheses around that term, if you don't put parentheses around it, you're not going to remember to raise 2 to the 5th power, and then you're going to get the stuff wrong. Okay, now we go to our calculator to do 8 choose 5. So I'm going to do menu 5 3, and then I need 8 comma 5. 8 comma 5, and then hit enter, and we get 56. And then this is an A to the 3rd. And then here we need to remember we're doing 2 to the 5th, which is 32. And we're doing B to the 5th. Now I can multiply the 56 and the 32 together, 56 times 32, I'm going to get 1,792. And then I have an a to the third and a b to the fifth. So that right there is the fifth term. If I had written it out, I would have my 0 term, my first term, second term, third term, fourth term, fifth term, etc. There'd be more. So this would be the fifth term. Yep, right there. Okay, let's try another one. This time we're going to find the seventh term. So again, whatever this exponent is, that's your row. And then here's my term. So it will be 8, choose 7. We always do the row and then the term. So 8, choose 7. Whatever is listed first, that is going to get raised to the 8 minus 7 power. And then whatever is listed second, now take that negative sign with it, okay? And write it in parentheses. Negative 2b, that is going to get raised to whatever the term is, to the 7th power. All right, 8, choose 7. Get your calculator. We're going to do menu 5, 3, and then it's 8, comma 7 for 8, choose 7. Hit enter and you get an 8. So all of this is an 8. This will be an a to the first. And now be careful, we have to do negative 2 to the 7th power. Now keep that in parentheses when you type it in your calculator. Okay, so negative 2 to the 7th power, you're going to get negative 128. If you don't put it in parentheses and you do negative 2 to the 7th power, well, in this case, because it was an odd exponent, it didn't matter. But let's say this was an even exponent, like negative 2 to the 8th power, how about? Versus negative 2 like that to the 8th power, you're going to get different answers. So it's because when you take a negative number to an even power, it should turn positive, but if you don't type it in the correct way, it's going to give you a negative. But in any case, we were raising it to an odd power, so it didn't really matter too much in our calculator. Negative 2 to the 7th is negative 128. Now remember, we are multiplying, not subtracting. And then we also have b to the 7th. So I have to do 8 times negative 128, and I'll get negative 1024, and I have an a to the first and a b to the 7th. So this right here would be the 7th term. All right, let's try one more of this kind, and then we have a different set. Okay, so the 4th term. So remember, 6 is the row, and the term is the 4th. So that would be 6, choose 4. Whatever the first thing listed is, write that down, and then subtract those two. 6 minus 4. Whatever the second thing is, that was a negative 5. Write that down and raise it to whatever the term is. All right, so in your calculator, 6, choose 4. So menu, 5, 3. Oops, I'll do it again. Menu, 5, 3. And then we need to do 6, comma 4. And we get 15. And then this will be an x squared. And then negative 5 to the 4th power, when you type that in your calculator, you get 625. And then multiply the 15 and the 625. And then that right there is your 4th term. So you can figure out the term without having to write the whole expansion out. Because this would be in the 6th row, so you would have a lot of terms. So this might be a faster way to get there. Okay, now this is a different type of problem. Similar, but different. So I'm going to give you the binomial, and I want a specific term. And the directions might say find the coefficient a. So basically, we just want this number that's going to be out in front of the term that has an x to the 5th in it. So I could expand this whole thing out, but keep in mind, this is the 12th row. I would have a ton of terms. And then I would have to hunt and peck for the term that involved an x to the 5th. I could do it that way, or I can use my formula, which I think is going to be a little bit easier. So n is the row, and this would be the 12th row. So I know it's going to be 12, choose something. And I don't know what that something is going to be just yet. So I'm just going to make a little box. Okay, and then the first thing listed was an x. So that will be to the 12 minus r, which I don't know what that is yet. And then the second thing listed is a 4. And that will get raised to whatever this r is. Again, I don't know what that is yet. But here's my clue. The clue is that I need to end up with an x to the 5th. Well, that's going to help me over here because I have an x to a power. I need to figure out what should go in this red box so that I get an x to the 5th in the end. So it's not going to be a 5 because 12 minus 5 is not a 5. So what value should go in the red box? 12 minus what will give me an x to the 5th? This has to be a 7. So if that's a 7, then this is a 7, and this is a 7. So let me write it out a little bit nicer. 12 choose 7, x to the 12 minus 7 times 4 to the 7. So let's get our calculator out, do 12 choose 7, and you'll get 792. And then this will be an x to the 5th. And then I have to do 4 to the 7th. And 4 to the 7th is a big number. Let's see here. It will be 16384. And I need to multiply that by 792. And I'm going to get 12976,128 x to the 5th. So the question was asking for find the coefficient a. So it was asking for this right here. Here is that coefficient in front of the x to the 5th term. So a is that. Okay, I got 2 more questions like this. All right, this one's a little bit trickier, but again, I'm going to follow my formula. All right, so this is one clue right here that we're going to be in the 8th row. So I know that n is an 8. R, I don't know what that is yet. X is whatever the first thing listed is. Well, that happens to be a 2x in this problem. And that's going to get raised to the n minus r, so 8 minus something, which I don't know yet. And then the y in the formula is whatever the second thing listed is, which in this case, it's a negative 3y. And that will get raised to whatever r is, which I don't know yet. Now, there's a clue here that I need to end up with an x to the 4th and a y to the 4th. So what's going to have to go in these boxes so that I get a y to the 4th? This will have to be a 4, right, to make a y to the 4th. And you see how if it's a 4 here, 8 minus 4 is 4, and I'll get an x to the 4th, like I'm supposed to. So that means that has to be a 4 as well. So let's go to our calculator and do 8 choose 4. You're going to get 70. And then we have to do 2 to the 4th power. So remember, 8 minus 4 is 4, and then do 2 to the 4th power, and you're going to get 16. and then I'll have an x to the fourth. And then here I'll have negative 3 to the fourth, which is 81. And then I'll have a y to the fourth. Now I'm going to multiply the 70, the 16, and the 81 together, and I will get 90720, and then I will have an x to the fourth and a y to the fourth. And the question was asking for what is a, this coefficient, in front of the x to the fourth, y to the fourth? That is this number right here. That's what the a is. All right, one more. Okay, I'm going to write out my formula again. And again, I know that this is the row, so I have the 10th row, so I know for sure that's a 10. And then I don't know what r is. X is the first thing listed, and the first thing listed is an x squared. And that's going to get raised to the n minus r, so that'll be to the 10 minus something. And then y in the formula is whatever the second thing listed is, which is a 7. And that will get raised to whatever this red box is, because we don't know what r is yet. But we have some clues. Here's our clue. I need to end up with an x to the 8th. All right, so what's going to have to go in here so that I end up with an x to the 8th? This is a little trickier. Keep in mind, I have an x squared, and then it's going to be raised to another power. Once I plug something into this red box, 10 minus something will be right here. And then what do we do with these exponents? We multiply them. Well, if I want to end up with an 8 here, this would have to be a 4. Okay, so then 10 minus what would give us a 4? So this would have to be a 6. Which means this is a 6 and this is a 6. Okay, let me just write it out nicely. So 10 choose 6. When you type that in your calculator, you're going to get 210. And then I'll have x squared to the 4th power, because 10 minus 6 is 4. And then I have 7 to the 6th power. Keep simplifying. X squared to the 4th. That's where the x to the 8th comes in. And then I do 7 to the 6th in my calculator, and I get 117649. And I multiply those two numbers together, and I get this. And then I have my x to the 8th. And the question was asking for what is this coefficient in front of the x to the 8th? That's this number right here. Okay, so, if you're getting stuck with this kind of stuff, you certainly could do the entire expansion and just hunt and peck for the term that involves an x to the 8th, and then write that out. I mean, you can do it the longer way. So again, going back, remember here where we expanded the whole thing out? You can do it that way and then find the third term, or you can use this formula and it'll just get you to the third term right away. Okay, so that's it for today. Have a good one.